Exchange high availability, database availability groups. All right, so in our continued exploration of the more, I'll call them management topics associated with Exchange 2010, we're finally making our way to at least what I think is one of the most interesting new capabilities in Exchange 2010. These are the concept of database availability groups. Now, what are DAGs? You remember back in the old days, back with the previous versions of Microsoft Exchange, Microsoft kept adding these three-letter acronyms to add additional capabilities that you could add in to your Exchange organization. We had single copy clusters, we had cluster continuous replication, we had local continuous replication, we had standby continuous replication. And all of these were various tactics that you could implement in order to create new copies of the database or extra copies of the database, or to create multiple locations where users could connect into their mailbox databases. Well, all of these got exceptionally complicated, obviously. When you've got 4 different ways that you can set up replication, well, you can see how that can get to be somewhat challenging. And so in Exchange 2010, Microsoft said, what we want to do is we want to create a mechanism by which multiple copies of a database, up to 16 individual copies, can be created, and those database copies can be spread out to wherever you want, other servers in your environment, other servers and even in different sites if you want. A cluster can be created, but without all that nasty Windows failover clustering, and effectively create a mechanism that creates seamless high availability for your mailbox databases. That's what database availability groups are. It's essentially the summation of all the nifty features of all these other three-letter acronyms into a single mechanism that you will use for replicating your data around to different servers in your environment. And in fact, it's very slickly designed. One of the best features of database availability groups is the fact that we now can do what we think of as traditional clustering, but without having to know all of that arcane knowledge associated with Windows failover clustering. We also don't necessarily have to have all of the pieces that are required for a traditional failover cluster. In this nugget, we're going to talk about how to create and configure database availability groups, along with all these interesting components associated with configuring those database availability groups for different needs. As you can expect, with the possibility of 16 different copies of that data moving around in your network, there are a lot of reasons why you would actually create different database copies. And the options here that we'll choose will make a difference as to whether you're creating them for archival purposes, for disaster recovery purposes, for immediate availability purpose, and what have you. But before we actually get into the process of actually creating and configuring those databases, I want to spend just a minute really helping you understand what a database availability group is and how they actually work. Now, a database availability group, think of it as invisible Windows failover clustering. A DAG actually leans on top of some of the components of Windows failover clustering, but you will never actually interface with the failover cluster manager. You won't have to build multiple servers that are connected together in a cluster. You won't have to have shared storage between all those servers. Now, we can do this because Exchange actually skins over all of the management functions of that failover cluster and presents you with your usual Exchange management interface for handling all of these individual copies. And we can do this because we have some of those new features like we've talked about before, this idea of database portability, where a database is no longer directly linked to the server that it was originally created on. Also, the elimination of storage groups means that a database is a database and we don't have to put them in storage groups anymore. What this means is that if I create a database copy anywhere else in my environment, I could potentially fail over to that copy at any point in time for any reason, and my users would immediately be able to work with that copy. This is a great thing. When we're talking about the replication of those databases, we're using classic log shipping. So my primary copy of my database, the active copy, essentially ships off the logs, the changes to that database over a period of time, to the other copies that are out there. And this is a configurable setting so that we can even lag some of that log shipping and lag some of that replication if we want to protect ourselves against database corruption. New also to Exchange 2010 is this idea of shadow redundancy to provide the sense of message preservation. If you think about it, If I have an active copy of my database and I'm sending out changes to that database to the passive copies elsewhere out in the network, there may come a situation where I have a network problem, or when a server problem occurs and some of those messages may get lost in transit. Well, with Exchange 2010, we have this idea of shadow redundancy, which essentially means that the Exchange server is going to keep a copy of any data that it ends up replicating elsewhere, and it will keep that in some sort of a shadow location, and only delete that after it has received an acknowledgement that the database copy on the other side has actually successfully written that change to itself. This ensures that we can survive a loss of any of the functionality, any server or network across our entire database cluster, and still preserve those messages without loss. One of the other things, if you're used to or if you're familiar with Exchange 2007, you know that sometimes those databases would come out of sync. And if they came out of sync for too long, Exchange 2007 didn't have a lot of good tools for reseeding that database if they got too far out of synchronization. Well, in Exchange 2010, we now have this idea of incremental reseeding to assist in these situations where we have two databases that have come significantly out of sync. What this does is it ensures that we can then resynchronize those databases without resorting to deleting the copy and restarting the synchronization from scratch. If your databases were very large, and whose aren't these days, that could be a very long period of time. And so being able to incrementally reseed those databases ensures that we don't have to go and delete databases and then recreate them whenever we have problems. Now, in order to do a database availability group, you are going to have some components. You are going to have at least 2 or more servers with Windows Server 2008 Enterprise Edition. That Enterprise Edition is required more or less because of those Windows failover clustering components that are underneath the covers. You're going to have 2 NICs per server, and you're also going to have 2 or more instances of Windows Server Exchange Server 2010 Enterprise Edition. Also, in addition to all of these components, you are going to have what's called a file share witness. Now, this file share witness is another server, a third server, if you will, that exists outside the database availability group. This third server doesn't necessarily need to be an Exchange server, although it can be. And it can be a file server, for example. And it essentially hosts a single file share that the cluster uses to verify that really it still is a cluster. What this is it prevents a situation known as split brain with clusters. When you only have 2, or I should say an even number of nodes, you want to prevent that, and the way you prevent that from occurring is by creating a third witness that exists somewhere else on your network that identifies who actually is the surviving members of the cluster. I'll show you how to create that file share witness. We're actually going to create that file share witness not necessarily on a hub transport server. We're actually going to create that file share witness on another file server so that you don't have to go and buy another Exchange server license to create that database availability group. Visualizing this file share witness is probably easiest through the use of a picture. I've actually drawn one up for you here. In the demonstration, which we're going to get to here in just a minute, we're going to take EX1 Nugget and one of the databases that's on EX1 Nugget, and we're going to use a database availability group to replicate it over to EX3 Nugget. This is a new server that I've created. It's just a simple mailbox server. And on that mailbox server, we will have both of the copies of one of our databases. Now, as I said before, in order to create that copy, we have to have this sense of a file share witness. And what I've created also for you is this FS Nugget server, which is a third server that's not part of the Exchange organization. This third server will host the file share that we will use as the file share witness for this cluster. And so in the demonstration, you're going to see EX1 Nugget as the primary server, EX3 as the holder of that passive copy of the database, and we're going to work just a little bit here with FS Nugget so we can create that file share witness. Now, when you're creating this file share witness, don't worry about the size of the contents of that file share. Really, there's not a lot of data that a cluster requires for that file share witness. It's really just a little bit of information there that's used to ensure that we know who is still a cluster and who has fallen off of the cluster, who is still the surviving members. So don't worry about the size there. It's not going to be that much. Let's actually go over to our Exchange organization here, and here's our Exchange Management Console, and we're taking a look at the mailbox servers that we've created. If you recall, back when we were looking at mailbox and the mailbox role, we created an additional database in addition to the default database. This is the default database, and this is the new one that we created. We also have a public folder database here as well. Now you'll notice that for this default database, we have one copy of the database here, which is currently mounted on EX1 Nugget. What we want to do is to create a second copy of this database on EX Nugget 3. Now the way that we go about doing that is first here inside of database availability groups. There are really 3 steps involved with creating that copy. The first step is to create a database availability group. That's what we're going to do here first. The second step is to add the necessary servers that will be a member of that group. And there can be more than just 2 servers. There can be actually, well, you can argue up to 16 servers. And then the third step is to actually create the copies and then start the replication across those servers that are going to take part in those copies. Let me go ahead and start this process by right-clicking here and choosing New Database Availability Group. You'll see here that we bring up a very nice wizard here, and we can give it, for example, a database group name. We'll call it my DAG. And I can assign a witness server and a witness directory. Now what I want to do first is click the New button here and not assign either of these, because I want to show you that by default the wizard will attempt to locate a hub transport server that does not have the mailbox server role in the local Active Directory site. If it can find that, it'll go ahead and create that witness server for you. But obviously, our site, we have only one server that has the hub transport server role. That's this server, and it has that mailbox server role. So we're probably not going to work. And as you can see here, we've actually failed this step in the process. What we need to do is to actually identify who that witness server is, as well as who the witness directory is as well. Now the server that we're actually going to use for this witness server, as we said before, is the server FS Nugget. Before we actually identify who the witness server is in the directory, we need to create that directory and also create a basic share associated with that directory. Let's go ahead and bring that server up. You can see here I have fsnugget.nuggetlab.com, and what I want to do is just simply go to a location on this server. I'm just going to go to the C drive because it's easy, and I want to create a folder, and we'll call this my witness. That's all we need to do. Step 2 is to go to Properties, Sharing, Advanced Sharing, and share this folder. This actually creates the share associated with the folder. You've done this before many times. Now there's a third step that's not well known associated with this creation. As I said before, the intent really is for this witness server to be one of your Exchange servers, but it doesn't necessarily have to be. However, if you are using another server that is not a member of your Exchange organization, one thing that you're going to have to do is to add the Exchange Trusted Subsystem Universal Group to the local administrators group on this server. You can see I've already done that here. Again, this is a universal group in your forest. Add this into the local administrators group, and this will give the Exchange organization the privileges enough that it needs in order to configure this file and this share to make it a part of the cluster. I've done this already here, so we can complete this process. We now at this point have completed exactly what we need to do to actually start creating this database availability group. I'm going to put in here FS Nugget. That's the witness server. And the witness directory, I need to do the full path to the witness directory, which will be c:/my witness. If I click the New button here, the wizard will then go through and create the database availability group. Now you'll notice that we've completed with a little warning here, letting us know that the specified witness server FS Nugget is not an Exchange server. This is an OK message. We can actually bypass this because if you'll see, we will actually create the database availability group with the witness server and the witness directory here. This is step 1. Step 2 is involved with actually adding in the member servers to this database availability group. And we do that by right-clicking and choosing Manage Database Availability Group Membership. Well, that's a hard word to say. In here, we want to add in the servers that we want to add to this database availability group. And as you can see, there are only 2 mailbox servers in my organization, so it makes this kind of easy. I'm going to click the OK button here and choose Manage. Now at this point, actually adding these servers into the DAG is going to take a period of time, so I'm going to pause to actually let this go ahead and create the cluster. And when we come back, we're going to start by actually adding in the mailbox databases that we want to add to this DAG. And we're back. You'll see that the process took about a minute. Sometimes it can take a little bit longer, particularly so if you're using servers that are in different sites. But this completed, like I said, not that long of a period of time. We click the Finish button here, and you can see that we now have 2 member servers that are a part of this database availability group. If I right-click here, I can choose Properties to see just a little bit more information. You'll see here the member servers again, the witness server and the witness directory, and some operational server information down here. But really, there's not much to look at this point. The final step that we want to go through is to actually create those database copies. Now recall again that we created this database. This was the default database right out of the box. And what we want to do is actually create a database copy by right-clicking and choosing to add Mailbox Database Copy. This will open up another wizard. As you can see here, we have our mailbox database name, and we need to identify the server that we want to copy this database to. I'm going to choose the Browse button here and choose EX3 Nugget because that's the other server. In a minute, I'm going to talk about this activation preference number here, so hold on to this thought for just a second. You see here that EX1 Nugget already has a copy of the database, and if I choose Add, we're going to go through the process of actually copying that database from one server to the other. And after a short pause to allow that database to start its synchronization, we'll click the Finish button, and you'll see now that we have 2 copies of our database, one that is mounted and one where the copy status is healthy. Now, obviously, we always want that copy status to be healthy, but there are a number of configurations that we can do associated with this database that will give us some different functionality associated with the database. Remember that when you have multiple databases out there, you may have some that are out there in case, for example, you should lose your primary server. You know, if you have to reboot your primary Exchange server at some point during the day, you want to have a secondary copy of the database that is local, that is well synchronized, that is always up to date, that can be immediately failed over to so that users don't lose access to their mail. Alternatively, you may want to have additional copies of the database, perhaps in other locations for disaster recovery purposes. So you may have a second copy of the mailbox somewhere out in another site to protect that mail from losing an entire site. Also, you may want to have an additional copy of the mail to protect yourself against database corruption. Imagine a situation where something happens, maybe a piece of malware occurs in your environment, or you just have some big problem with Exchange someday, and your actual mailbox database corrupts in some horrible way. Well, it is possible to create a sense of lag across one or more of the replications so that the database on the other side will still be preserved and will not actually receive the corruption that you have inside of your primary database. So you can see there are a lot of reasons why you'd want to create more than just one copy of your database because there are multiple different needs that you will have. If we want to take a look at some of the properties here of these mailbox databases, you'll see here that we can choose to suspend the database copy here. Now what this means, again, because this is the mounted copy here, is this will actually suspend the replication of that database. I'm going to do that here against the secondary database. You'll notice, however, that in doing that we get one of the very rare "Are you sure?" prompts associated with Exchange. Because suspending that replication is something you should probably only do in a very extreme circumstance. If I choose the Yes button here, you'll notice that we've actually suspended the replication from the primary database to this passive database on the second server here, EX3 Nugget. If I right-click again, I can choose to resume that database copy or update that database copy. Now the reason why you would choose to update the database copy is when that synchronization has gone significantly out of, when the synchronization has gone on for a very long period of time, or the suspension has gone on for a very long period of time. What this update database copy is it provides a mechanism for you to identify a source server for reseeding the database. Now in our case we only have one server here, but you may desire to actually use a different copy of the data to reseed this failed synchronization. You can also choose to delete the files if they exist on the target path and continue the update process, or simply cancel the update process, and then automatically resume data replication from the active database copy, or just to simply leave the database copy suspended after you've completed that database copy. Down here at the bottom, we have the ability to select a database availability group network, which we're going to talk about here in just a second. Now, be aware that updating this database copy can take several hours depending on the database size and hardware performance. And so if you really want to do this, be aware that it's going to take a while to complete this process. If you hit the update button, it'll start that update process. Now what I want to do here is not necessarily update the database, but simply to resume replication here. And you'll notice here that we'll actually go through a process where we resynchronize the database to the primary. Give it a second or two, and it's now back to healthy status. Now this can take a longer period of time if, for example, you're spread by a latent network connection, or if you've got a mailbox server with a lot of mail that's changing quite a bit. But this is the mechanism that you would go through to actually suspend a database if, for example, you wanted to peel off a copy and use it for some sort of e-discovery purposes, or you wanted to archive it in some way, or if you wanted to use it for test or development. This is the process you would do for suspending and peeling off that database. Also found in this location is the selection for where you'll identify when you want to change who is the active database as opposed to the passive database. Think, for example, if you need to go and reboot EX1 Nugget during the middle of the day. Perhaps you need to install a patch, or perhaps it's experiencing some sort of problem that will be fixed through a reboot. One way that you can actually just simply change who is active is to right-click and choose Activate Database Copy. What this will do is it will switch who is the current mounted copy of the database and who is the passive copy of the database from EX1 Nugget to EX Nugget 3. You'll see here after a second or two, we have the mounted copy, and now the healthy copy is back on EX1 Nugget. So what this does is it provides us a way to switch who is primary for that particular database copy. Now you'll notice when I did that, if I go back to here and choose Activate Database Copy here, there is a selection down here that lets me choose the mount dial associated with the mailbox server host EX1 Nugget. So when I actually go to change the ownership of this database, do I also want to change some of the parameters associated with failover? There are 4 parameters here, and I'll just kind of explain them in basic terms. If you choose lossless, the database will not automatically mount until all the logs that were generated on the active copy have been copied to the passive copy. So you ensure that you don't lose any data. Good availability, if you specify this value, the database will automatically mount immediately after a failover, but only if the copy queue length is less than or equal to 6. What this means is if there are not that many queued up copies that need to occur, then you'll go ahead and complete that migration. Now, best effort, however, will just go ahead and remount the database regardless of the copy queue length. Now, this can actually involve some data loss, but it ensures that you get that mailbox remounted to somebody else if you experience a problem. And lastly, best availability is like good availability, except the database will automatically mount only if the copy queue length is less than or equal to 12. So you can change this parameter when you actually go through changing who is the owner of that database. What I want to show you here is looking at some of the properties of this database to give you some idea for what these copy queue lengths are, as well as some of the other parameters. Here we're looking at that mailbox database copy on EX1 Nugget, and it has a status of healthy. Now obviously anytime that we have a sense of replication between 2 servers, there's going to be some sort of data that has to get queued up as it gets moved from one server to the other. These statistics here will give you a very good understanding about whether you've successfully created good replication between those 2 servers. Do you have enough bandwidth? Do you have enough throughput? Are your servers powerful enough to support the replication? If your copy queue length or your replay queue length ends up getting very high, well then you can figure that you probably are lacking something. You have a bottleneck somewhere in your network that you should probably resolve before too long, or before it ends up causing a problem down the road. Also down here is this activation preference number that we actually skipped over earlier in this nugget. You'll notice the activation preference number for this copy is 1, and if I go down to the mounted copy, the activation preference number is 2. Now the activation preference number is a mechanism for you to identify what the failover order should be if you end up losing the primary copy of the database. Think about this. As I said before, you may have multiple copies of this database. One local so that you have good failover. One in another site so that you have disaster recovery potential. Even another in a lag site so that you can protect yourself against corruption. What you want to do is to make sure that you identify the order of failover, smaller meaning better, for all of these copies so that you make sure that you fail over to the proper copy and that you don't end up failing over to the wrong copy that's in the lag site. This is the concept of the activation preference number, and you really want to watch these as the number of copies in your organization goes up. Here under status you can see whether or not we're seeding the database. We can see some log time information here, just some basic statistics associated with these databases. Now you might notice that nowhere in any of these screens have we found any information about this concept of lag. And the reason for that is because Microsoft has removed the lag information from the Exchange Management Console and brought it into the Exchange Management Shell. And while we're waiting for this Exchange Management Shell to pop up, I want to let you know about the two different types of lag that you can actually incorporate into a particular mailbox copy. The first is the replay lag time. Now, the replay lag time is effectively an amount of time that you select for how long should that secondary copy of the database wait before it begins replaying log files into its database. It's going to receive those log files as part of the log shipping functionality, but how long do you want it to sit on those log files before they actually get replayed into the database and actually make changes into those databases? You would use the replay lag time whenever you want to create or protect against database corruption. If you set a replay lag time of 2 days, that gives you a full 2 days to fix any sort of corruption in your primary database before those logs will begin to replay into that secondary database. The second type of lag time is a truncation lag time. And this is done to identify how many days should you sit on those log files after they've been replayed, but before they eventually get deleted. Now, the idea here is that you may end up having some situation where replaying some log into your database actually creates a problem, and you may want to roll that back out. Well, you create a truncation lag time so that you can identify, I want to keep those log files around for a particular period of days so that I can potentially roll them back out and protect my database further. Now, the way that we go about actually doing this is, as I said before, here inside of Exchange Management Shell. I'm going to paste in here a command line. It's called set mailbox database copy. I need to identify what the database is. In this case, it's identity mailbox database, and then the database name / server name, and then dash replay lag time, and then dash truncation lag time. Now, these have to be in a whole number unit of days, and so really you're just going to be adjusting these to a whole number unit of days. But this is the syntax you're going to use for identifying when you want to set the replay lag time or the truncation lag time again on a specific copy of that database. So be aware about this, because you may want to set this for some of the copies of your databases that you have. Now, the last topic that we have to talk about here goes back to these database availability groups, and this area down here that we kind of skipped over called called networks associated with the MyDAG database availability group. When you are doing any sort of replication, any sort of clustering, if you're familiar with Windows failover clustering, you know that failover clustering really likes to have its own set of network cards and its own set of network interfaces for doing that replication. You'll notice down here that we have network interfaces here that look suspiciously very similar to the ones that we saw in Windows failover clustering. If we want, we can identify a specific database availability group network for where we want that traffic to go across. If we have multiple network interfaces on our servers, then we can identify which of those network interfaces we want to use for identifying how we're going to pass that replication traffic across of our network. Again, segregating this network traffic out onto its own subnet helps protect our production network from being oversaturated with replication traffic. Again, particularly the case when we have lots and lots of those database copies and multiple copies going to multiple locations. So be aware of these database availability group networks and consider creating your own special subnets, especially if you have lots of databases that you want to replicate into lots of different locations. So what have we talked about in this nugget? We've really focused on this really interesting topic of database availability groups. And really, you could argue that DAGs are in some ways Exchange 2010's crowning achievement, because they provide the capability for you to really identify how you're going to preserve the most critical part of your Exchange organization, that which is your mailbox data. In this nugget, we talked about DAGs and all the new fancy features associated with them. We talked about how to create and configure them and all the interesting characteristics for how you will create multiple copies and why you will create multiple copies. I hope this has been informative for you, and I'd like to thank you for viewing.